Okay, thanks everybody for joining us. We're going to kick it off here. I am Sam Bakken. I am Content Marketing Manager here at NowSecure. Thanks again for joining us for our webinar series, Mobile Penetration Testing, the Trilogy. And today's episode is episode 2, Return of the Backend Network. Just to give you a quick overview of our series here, each episode focuses on a different key area of the mobile attack surface that mobile penetration testing must cover. So today, NowSecure Solutions engineer Michael Krueger will explain how to identify vulnerabilities in communications to and from an app, and then also about testing back-end servers. We will be concluding the series in January with episode 3, entitled Attack of the Code, which will explain finding security flaws in mobile apps by dissecting code through reverse engineering and code analysis. And at the end of the presentation here, I will provide you with a registration link so that you can make sure you're getting the whole story. Now, real quickly, I want to make you aware of a couple of ways to get more information from NowSecure about mobile app security specifically, and then mobile security in general. So first of all, if you don't already, I encourage you to follow us on Twitter at NowSecureMobile, where we share resources and advice about mobile app security. The next item there, I encourage you to subscribe to our once-a-week mobile security news digest, MobSec5, for insight into the week's mobile security news. And then finally, visit our website where you'll find a bunch of great resources and blog posts to help you with your mobile security objectives. Now, I am going to introduce you to today's speaker, Michael Krueger. Michael helps NowSecure customers design and implement mobile app security solutions. Previously, Michael was Senior Cybersecurity Engineer at MITR, specializing in digital forensics, vulnerability assessment, and reverse engineering. At MITR, Michael helped multiple organizations build and maintain app security programs through the evaluation and selection of tools, performing deep technical testing, and coordinating across multiple teams of engineers. At NowSecure, he's an invaluable resource to our customers as they confront and overcome mobile app security challenges. Now, finally, before I turn it over to Michael, we want to make this series interactive, so please don't be shy about submitting questions to the host using the chat function in the GoToWebinar interface. And Michael will handle those questions at the end of his presentation. And with that, Michael, over to you.
All right, thank you, Sam. Just want to make sure you can hear me okay.
Yeah, we're all good, Michael. Thank you.
All right. All right, thank you for the introduction, Sam, and welcome everyone to part 2 of our 3-part series. Today we're going to start off talking about data in transit as it relates specifically to mobile app testing. We're going to dive into a few of the top concerns and even touch on some privacy issues that are often overlooked when testing. Finally, we're going to explore some concerns to keep in mind with the mobile app's backend server infrastructure. Then we'll wrap up with some common tools to get you started today. Now, before we continue on, I just want to highlight this slide right here. There are 4 areas of focus in mobile pen testing. Commonly, we test 1, maybe 2 of these focus areas, and then we forget the rest. I know I'm guilty of that. I like mobile forensics and data recovery. That's where my expertise really lies. So I tend to focus on that, while assuming that maybe the data in transit is mostly secure. But as security analysts, we really have to remember that to get a thorough assessment of an app, we need to prioritize not 1, not 2, but all 4 of these areas. All right, let's start with data in transit. By data in transit, we're referring to any application data that's sent over the network to either another device directly or to a back-end service. Today we're focusing on 3 major concerns with respect to data in transit: insecure communication, insecure authentication, and insecure authorization. Now, all of these concerns can be found in the OWASP Mobile Top 10. OWASP is the Open Web Application Security Project, and it's a community effort to increase the security of the world's software and really enhance security awareness. And they have a bunch of top 10 lists. They compile a community agreed upon set of concerns that most commonly plague applications today, be it mobile applications or web applications. It's an extremely valuable resource for new and experienced testers alike, so it's something I highly recommend you check out in more detail. Before going any further, I'd like to quickly review the concept of a man-in-the-middle scenario. Simply put, a man-in-the-middle is an attack wherein the attacker relays and maybe even alters the communication between 2 points, where both of those points believe that they are communicating directly with each other. That's important. It's an attack that aims at circumventing mutual authentication, or otherwise known as the process by which a client must prove its identity to the server, and then the server must prove its identity to the client. While we may talk about man-in-the-middle in the context of a system vulnerability, man-in-the-middles are not only an attack technique, but they're used in the development stage of applications. Be able to see the data and validate it between a client and a server is often quite helpful during that initial development stage of an application. Important thing to remember for developers is that not to expose those vulnerabilities during that development, not to expose that when you go to the production level. And we'll talk about that more in a little bit further on. Having a little bit of slide lag here. We often say, don't invent your own crypto. Use existing libraries. Why do we say that? Well, security design is hard and it requires specialized knowledge to properly make a secure application. This is especially true when we're talking about cryptography, certificates, authentication, authorization. There are a lot of community vetted libraries out there already, and really implementing your own at this point is just asking for trouble. Secure application design is often an afterthought, though, second to making the applications function normally. So as developers, sometimes we just want to get that application out there, we want it to work, and then afterwards we realize, oh, we really need to apply security on top of that. And really we need to get into a different mindset wherein we're developing that application with security at the heart. Now, documentation for these secure libraries and APIs are notably confusing, and they're often conflicting in the many online resources that are available to a developer. So that's really, it's no wonder that while the intent behind applying some of these libraries is good, the implementation is probably not as sufficient as it should be. Sometimes that poor implementation is just due to an honest oversight on the developer's part. There's a lot of information out there, and it really is confusing. So we really encourage developers to take their time and read through all of the API documentation and get help if they're not quite sure how to implement it properly. Certificate validation issues are sometimes the cause of vulnerabilities in an application. Mobile app and an endpoint successfully connect to perform a TLS handshake to establish that secure channel. However, the mobile app fails to inspect the certificate offered by the server, and the mobile app unconditionally accepts any certificate offered to it by the server. Mobile app's then susceptible to one of the man-in-the-middle attacks through a TLS proxy. Now, something that I've seen quite a bit actually just in some of my own research and poking through some of the freely available App Store apps, and really developers do this. Why do they actually accept every certificate? Well, sometimes in development they were using a self-signed certificate while they were developing, and they just forgot to turn off that accept all certificates. Sometimes it's easier, sometimes they don't have the money to get a fully signed by a trusted CA. They don't have the money to go through that, and they just want to get their app out on the App Store. So they're doing the least amount of work possible. Other times it's just really that, as I mentioned before, that honest oversight. They forgot to turn that back off and only accept trusted certificates. Sam, could you advance that slide for me? I seem to be having a little... There we go. All right, so let me talk a little bit about how one might test for that certificate validation issue. This is a diagram for a tool called man-in-the-middle proxy, or MITM proxy. Man-in-the-middle proxy, it's a console tool, and it's one for interactive examination and modification of like HTTP, HTTPS traffic. So in order to set up this test, it's really easy actually. Install man-in-the-middle proxy on a laptop or machine of your choice. You'll need Linux, so we always recommend. Put it in a VM. NowSecure actually sponsors an open source Linux distro called Santoku Linux, and I'll discuss that a little bit more at the end of this presentation. Or you can use really any Linux distribution of your choice. So set that up on your laptop and install man-in-the-middle proxy on top of that. Make sure that that laptop is attached to the same network as your handset. The handset can be an Android device, can be an iOS device. In the context of this, I'm going to show you Android just because when I'm testing, that's my handset of choice. All need to be on the same network. Make sure that your network has a live internet connection, because we still want that application reaching out to its servers. Now, if you install the man-in-the-middle proxy's certificate, so man-in-the-middle proxy actually has a certificate generation, and it will sign its own certificate. If you install that certificate on your handset and trust it, you'll be able to man-in-the-middle any data that's coming from the handset to man-in-the-middle proxy. However, at this stage, in this test case, we don't want to install that certificate yet. We actually want to see if any certificate presented to the application, whether it's trusted or not, is accepted. Now, specifically with the handset, there's a couple of setup things that we need to take care of before we move on. Once you connect that handset to your network, as you remember, I had a specific IP address associated with the laptop. That was 192.168.10.66. We're going to go into the Wi-Fi settings on the Android device and modify that network, and then update that network's gateway to actually point to that laptop. So what that's doing, that's instructing the device that its gateway is now that man-in-the-middle proxy or that laptop before any traffic further continues on. And that's going to put man-in-the-middle proxy in the middle of our communications such that it can see, hopefully, or hopefully not in this case, hopefully not see any of the traffic that's flowing from our application out to the internet. Now, in iOS, just stepping back 1 second, in iOS, you can also do the same thing. Going into your Wi-Fi settings there, you can press the little I or information icon by the Wi-Fi network, and you can set the router option. Rather than gateway, it's called router, and you can set that to the IP address to accomplish the same sort of forwarding. Speaking of forwarding, on the laptop or the system with man-in-the-middle proxy installed, you'll need to configure routing via IP tables to forward traffic. So the man-in-the-middle proxy application internally runs on TCP port 8080, but externally it has to listen to ports 80 and 443, HTTP and HTTPS. So IP tables should be configured as you see on the screen currently. Now, if all goes according to plan, once we start up man in the middle proxy, should start seeing some HTTP traffic flow through that proxy. If you're not seeing anything immediately, don't worry. Open up a browser, visit a non-HTTPS website such as http www.cnn.com or some other non-HTTPS site to test. You should start seeing some data flow down the screen, as you can see on the left. Now we're going to open our target application. Now, if certificate validation is implemented correctly, we shouldn't see any HTTPS traffic appear. Ideally, on the handset itself, we should also see a pop-up alerting us to an invalid certificate. Sometimes there might be just an error that something went wrong or that there's no internet connection, but that's still better than the worst case scenario, which is we do see HTTPS traffic here in man-in-the-middle proxy, and everything within the application works perfectly. As you can see from this screenshot right here, the application that I was testing did actually, even though it was protected by HTTPS, that HTTPS traffic was getting through without any sort of trusted certificate being installed on the phone. So it was actually accepting any cert that was presented to it. So unfortunately, that is a common vulnerability that we are seeing in mobile applications still today. Now let's change our thought process just a little and widen the aperture of what we're looking for. Privacy concerns for mobile applications are on the rise. You hear about it in the news today, but it's not just in relation to encryption. Now, take a step back, and I want you to think, what is the application that you're using? What's that application that you're testing, and where are you going to use it? If you were in a crowded room right now, what information about yourself would you feel comfortable shouting out to everyone? Would you feel comfortable shouting out your phone number, your social security number, your home address? Now apply that same thought process to mobile applications. The message that I just sent with that chat application isn't the only thing that I just sent. That data stream probably included other information such as username, information about me or my device, ad network data, analytics data, who I'm communicating with, where I was physically when I sent that message, numerous other data points. Often this data, or metadata as it's often referred to, isn't protected with the same safeguards that the message or primary data was. But it's no less important to protect, or at the very least understand what you're communicating. Let me give you another example. Let's say you work for a retail store chain and you're investigating a competing company. Take a bunch of pictures of pricing, plan to send those back to your boss. They're big pictures, so you're probably going to attach to the store's Wi-Fi to use your company's messaging app. Saves on data that way. Well, that app encrypts the pictures themselves. Your authentication information that includes your company's email address, that's actually sent in the clear. So the competitor's network just so happens to be scanning for flagged keywords, and your company name is one of those. It alerts an administrator at corporate when it sees that information flowing in the clear across their network. Now, your pictures were never compromised, but the competitor still got something just as valuable. That's the knowledge that your company may be in their stores, researching them, investigating them further. That's something that a lot of app developers really aren't considering. They're not thinking about just protecting what they consider the most important data, but the data of the user themselves, which really should be considered to be just as important as whatever message or encrypted data there is. That's just one of many examples. It's also health applications leaking personal information, maybe in violation of HIPAA regulations. Those may face steep fines if that health data is compromised. It behooves both users and developers to look for this personal data leakage. Now, most importantly, don't overlook third-party SDKs. Don't overlook ad networks, social plugins, and other things like that that may be installed with the app that maybe you're not specifically, if you're a developer, that you're not specifically controlling. Ask yourself, what data are these collecting, and do they protect it? What are they doing with it? Similarly to the last example, I like to use man-in-the-middle proxy, or really any other tool, and we'll go over some more tools later, such as Burp Suite, to investigate. In this instance, I'll install the man-in-the-middle proxy certificate that I talked about before. In this case, I want to see all the data that is coming from that mobile application through my proxy and out to its servers. I really want to have as much visibility as I can. Now, a couple of researchers actually did just this, and they did it at a large scale. I actually included a link on this slide to the research paper that those researchers did. It's very interesting, the information they found on what popular apps and the privacy data that those apps are not only collecting but sending out. I highly recommend, it's not that old, it was published last year, highly recommend that you go to the URL in the lower right corner and have that for your resources. Very interesting read. Also, it's a good time to remind everybody that if you do have any questions, please do submit them. We'll try to answer them at the end of this presentation. All right, before moving on, let's quickly review the difference between authentication and authorization, because that is something that a lot of folks actually get confused. So authentication is the process of sending credentials in an attempt to connect to a server. Authorization, on the other hand, is the act of gaining access to a resource because the permissions configured on it allow you that access. So just because you can authenticate to a system doesn't mean that you have full authorization to use all of the resources of that system. And that'll become more important as we continue the testing discussion. All right, so let's start with talking a little bit about insecure authentication. So this is one of the first things that comes to mind when thinking about network issues in general with a mobile application. And this is actually listed on OWASP's mobile top 10 list as one of the most common issues. And in fact, even more so common amongst insecure authentication is session issues. Session issues, we may find anything from session fixation attacks, lifetime risks, failing to log users out, session identifiers. These are all types of insecure authentication that may weaken your mobile application architecture as a whole. So the session prediction attack focuses really on predicting those session ID values. So when a server responds back with a token or a session ID that client can communicate with, it should be fairly securely hashed. It should be random. It shouldn't be easy for an attacker to guess or generate that ID. However, some bad implementations use session IDs that are composed by a username or other predictable information like a timestamp, maybe an IP address, or, as I've seen, sometimes in the worst case, that information is used in clear text. So it may be session ID equals user1, and that's extremely predictable from an attacker's standpoint. Apps sometimes don't actually log out of the server side of the application. So when we say failing to log users out, your client, your mobile app itself, may destroy any session information locally, but it never actually contacts the server to destroy that session on the server side. So the app merely discards its copy and then moves on. However, that session is still actually active, and if regenerated or captured could be replayed by an attacker. Now, similar to client-only logouts, the server may fail to expire a session within a reasonable amount of time as well. So let's say that you do log out, but it doesn't expire that session for 24 hours. It means an attacker has 24 hours from the time of your logout where you're not using that session anymore to try to replay that or try to take advantage of that. So we also recommend looking for reasonable timeouts on some of these sessions. There is some guidance online available, but it really varies with your implementation and the level of security that you demand. Now, a common problem in mobile apps is offering up information to unauthenticated requests when they come to those endpoints that service mobile apps. So one of my favorite examples of insecure authorization. Before we were talking about insecure authentication, this is authorization. So it's trusting the client to play by the rules. The server is trusting the client. Should be the other way around. For example, if the mobile app knows the user's privilege level and offers menus, options, or other features that are appropriate to that user's level, that's normal. But if the server doesn't check that that user has the right or the privilege to execute those requests, then there's usually a larger problem at hand. So if the server is trusting the mobile code to only generate requests appropriate to the user's privilege level, that's a classic insecure authorization finding. So what you can see here on this slide is a simple response that the client uses to decide if the user has administrative controls or not. When we intercepted this, we simply had to change that value of isAdmin to true, from false to true, and the client awarded us full administrative access without ever checking with the server to see if this is authorized. All right, so let's move on a little bit into server-side security. Assessing server-side security is a topic we could spend a lot more time than we have today. The ability to test backend server really varies drastically with each installation, and even more importantly, if that server is owned by you or if it's owned by a third party. I really like to warn everyone that performing scans and checking for server vulnerabilities often look very similar to an intentional attack, and unless you've really received prior authorization to perform these tests, may well raise red flags against a service's network team or provider if you haven't previously coordinated with them. So most mobile backend issues really fall within the larger bucket of common server issues. And I recommend starting with OWASP's top 10, which is separate from the mobile top 10, but it really calls out a lot of these common server issues that you may see. Calls out various injection attacks as being at the top of the list. So your SQL injection, your cross-site scripting attacks, command injections, those typical ones that you're going to see not just in the mobile application space, but in web server assessment, web application assessment, all of those server-based attacks. So your server should be validating all data that it accepts from the client, regardless of if that client is authenticated and authorized. So again, with those SQL injections, check every bit of data that's being submitted. Validate it, sanitize it if needed, but don't just accept it at face value. The APIs that your server makes available should also be checking that the requests against that API are authorized. So don't just answer any request assuming that the only requests that are being made are from an authorized client. Definitely have the server checking. As mentioned before, session issues may arise if that server issue relies completely on that client to manage those sessions or tokens. Ensure that all session invalidation events are executed not just on the mobile app, but on the server side as well. And then the discussion of weak ciphers, and I wanted to talk a little bit more about that. So When a server connects with a client, a handshake or a negotiation happens between the server and the client to decide whether to use SSL or TLS, which version of the protocol will be used. So the negotiation phase includes a step to decide what ciphers or cipher suite will be used. TLS sessions use multiple ciphers, and each performs a different type of operations, such as hashing, signing, encrypting, so on and so forth. Periodically, though, new vulnerabilities come out and cipher suites are deprecated. Developers often forget to update which cipher suites they support. And again, we're talking on the server side here. But they leave them available for backwards compatibility. They continue to support vulnerable ciphers, opening up that server to potential attack. Thankfully, though, there are many options that you have to explore what ciphers your server supports. They usually do a pretty good job of telling you which ciphers are now deemed insecure, which ones you can continue using with reasonable assurance that there haven't been largely disclosed findings. My favorite is Qualys's SSL Labs SSL test. And what you're looking at here is an actual screenshot from that run against a live server. You can see that the result of running that scan, RC4, that hashing mechanism for TLS is now considered broken and shouldn't be used anymore. But it looks like this server is still supporting that cipher suite. So that's something that from a development standpoint or an architecture standpoint, the owners of that server would want to go back in and they would want to turn off the support for that specific cipher suite. Now, talking about multiple tools, again, you can accomplish the same thing with Nmap. And I like Qualys's SSL Labs, but one thing to keep in mind is that every scan that you run with that utility shows up in a recently scanned list that's made publicly available. So if you're still in that security testing stage and maybe it's your own server, you may not want to expose that server to the rest of the public, say, hey, this server has potential vulnerabilities. You may want to do it a little bit more quietly your own. And that's where Nmap can come in, and it can accomplish very much the same thing with the command that I've listed above that calls two scripts for checking certificate information and weak ciphers. Similar to Qualys's scan, identifies the same weaknesses. So you can see here under ciphers, it shows TLS, RSA with RC4. So again, it gives that a grade C, similar to Qualys's scan. What it said is that that is now deemed an insecure cipher. Now I wanted to talk about, since it looks like we're getting a little short on time, I wanted to talk about one or two more things briefly before I wrap up. Intelligence gathering is something that should not be overlooked when we're talking about network or backend testing. I like to find out as much information as I can about an application, such as who it talks to, who those servers are registered to, where those servers are, well, at least probably located, and so on and so forth. And that's kind of that reconnaissance or intelligence gathering phase where you really want to know as much about the overall infrastructure as you can. And that's not only from a usage perspective, but if you're going to continue down that back-end pen testing path, this gives you a lot of information back on what services are running on that server, such as maybe outdated versions of Apache, or if there are ports opened that are potentially a path for further exploit. Any of those things, that's really covered under that intelligence or scanning, but that intelligence gathering. And even if you're testing an application that you own, it's really just as good to see what you look like to an outsider. It really never hurts to see if those third-party SDKs are communicating out to other services without your knowledge. So setting up your laptop again as a proxy, you can set Wireshark to sniff all traffic. And if you navigate at the top of Wireshark, if you navigate to statistics and then select endpoints, you can actually see a list of all IPs that your handset has reached out to. Along the left-hand side, these are all the IP addresses that were contacted. And what I often do is I actually list out each one of those IP addresses, and then I'll run a whois or maybe some IP geolocation issue. Granted, those aren't always accurate, those aren't always up to date, but I like to at least get a little bit more information about where those are geographically, who potentially has registered those, so on and so forth. So this is a really good method to identify kind of those mobile app endpoints, if you will. Well, we're just about out of time, but before I wrap up, I did promise a quick overview of some tools to get you started. At a minimum, you'll want to start with a system with Linux running on it. I would assume most of listeners probably already have that or have access to that. But I do like to recommend Santoku Linux. Santoku is an open source Linux distro sponsored by NowSecure. Really has a wide range or wide collection of mobile pen testing tools, everything from reverse engineering to some network analysis to backup analysis for both Android and iOS. So I definitely recommend checking that out. You'll also want a handset to test. I use a separate Android handset, and I actually have it rooted just for ease of testing, especially if I'm using some of the other maybe device forensics that Katie talked about in part 1, or some of the reverse engineering that we'll go into in part 3. That rooted Android device is that's my device of choice. However, for the sake of today's test, none of the tests that we described should require root on a handset to function. Here's a list of some recommended tools and some documentation, and that should really at least get you started with the network side of app pen testing. If you have any questions on any of this software, please feel free to submit a question. Again, Qualys's SSL Labs, Nmap, Man-in-the-Middle Proxy, Burp Suite, IP Fingerprints, which is just one of many options for IP geolocation. Again, just a warning, IP geolocation is not always accurate, especially when you run geolocation against web services or cloud hosting services such as Amazon's AWS. So again, it's not always accurate. And then Santoku Linux, and finally Wireshark. And really with these tools, that at least gets you started with an initial tool setup to start to do some of this network pen testing. Back on the other slide, I did mention one other Linux distribution, and that was Kali Linux. For those that are familiar with the name Backtrack, Kali is what Backtrack has evolved into. Again, it's a wider, it's got a wider focus, more around exploitation and penetration testing that's not just mobile application specific, but for some more of those web-based tests, especially against the server, that's another distribution that you may want to check out. All right, so just a couple of quick pointers that I advise anyone newer to mobile pen testing to keep in mind. Don't just focus on trying to break into the payload of encrypted communications. Often we get wrapped up in that. You know, that's kind of that prime golden treasure there, but often a lot of valuable data, including some potential useful data for executing exploits, it's located in the metadata. It's located in the clear. So don't overlook that. And I repeatedly mentioned just one or two tools throughout the talk today, especially with TLS proxying. You know, I mentioned Man-in-the-Middle Proxy, I mentioned Burp Suite, but encourage you to try multiple tools. Heck, use multiple tools on every test and validate the findings from one, check it against another. Find those tools that you're most comfortable with using and use those. There's a lot of different tools out there that accomplish the same thing. So find the ones that you're most comfortable using. And again, if you're testing a third-party application, I highly recommend you get permission before conducting any sort of vulnerability scan against their backend servers. And then, as with any sort of network analysis, network data adds up quickly. There's a lot of information to parse through, especially by hand. So utilities like grep, they're your friend. And to wrap up, remember vulnerable data exists in more than just the payload. Try using both trusted and untrusted certificates when intercepting data in transit. If you're not getting anywhere with an untrusted cert, install a trusted cert and have a look into that data stream. There may be more to exploit than just looking for initial certificate validation issues or certificate pinning issues. So, and then don't underestimate the time or effort involved in network-focused testing. We went over this talk in a little over 30 minutes, glossed over a lot of topics in a short amount of time, and I didn't even come close to exhaustively discussing everything. Plan accordingly with your deadlines. This does require a lot of effort and time.
All right. Thank you, Michael, for that presentation chock full of information, as you said. Really quick, as we kind of collect some of the questions that came in, and I encourage people to submit more questions now. We'll continue taking those questions and answering as many as we can with the time we have available. So please get those in. But in the meantime, I just want to remind everybody really quick about the third episode of our mobile penetration testing trilogy. That's going to be entitled Attack of the Code, and during that session, our expert, Sebastian Guerrero, will be doing and explaining code analysis and reverse engineering to kind of dissect mobile apps code and find security flaws in that way. That will be held on Thursday, January 19th, and that'll be at an earlier time than normal, which is 11 a.m. Central and 9 a.m. Pacific. And right there on your screen, you'll see that we have a link. You will also, as attendees, be receiving the slides for this presentation, and so any of the links to tools or anything else like that, you will find in those slides, and they will be clickable so that you can to them. So with that, I think we are going to start with some questions here, Michael. Number one is, why would a server support older cipher suites for mobile?
So that's an interesting question. Really, and I think I briefly mentioned that developers enabled those older cipher suites for backwards compatibility. For example, I don't think it was until, with Android, I don't think it was until version 4.4.2 or maybe even 5.0 that TLS 1.2 was even supported. So it's always a security versus usability argument. Developers could really lock it down and they could mandate only TLS 1.2, but then again, how much of the market is still using older Android devices, and how much would that limit their user base? So it's always kind of a balancing game there.
All righty. And then we have another question, kind of a two-parter maybe. Somebody asked, how is the SSL pinning issue tested? Using a trusted or untrusted certificate? And then the same person is asking for some elaboration about like why to use a trusted certificate as well. What's the purpose for that? So hopefully that makes sense, Michael.
All right, so let's start with the beginning part. So using a trusted or untrusted certificate. Well, in this case, you want to use a trusted certificate. The reason for that is what's actually happening is cert pinning is relying upon a previously verified certificate. So it's no longer, it's actually kind of breaking the whole certificate uh, verification model, because it's saying now, oh, I no longer trust that certificate authority to properly validate a certificate. So the certificate that I now install to my host and pin, that is the only certificate that I will accept. That's the only one that I believe or know to be a valid certificate. So when you're testing certificate pinning, you want to install that man-in-the-middle proxy trusted certificate, and you're going to look for if that application still works or not. If certificate pinning has been implemented, then even with installation of a trusted certificate, that communication should fail. And then following up on the second part of that, which was what's the purpose of using a trusted certificate? Well, again, that's more, it's not so much to identify the vulnerability of a man in the middle, because when you trust that certificate, you're basically saying that you know better than the certificate authority, that you have validated that that middle party is actually valid. What you're looking for, why that's useful, you actually want to look within the data itself. So one of the things that I always do when I install a trusted cert, I'm looking at the usernames and the passwords that are being sent from the mobile application to the server, and I'm validating that maybe they've still been hashed. Yes, it's in an SSL tunnel, but best practice dictates that there's still some sort of hashing or additional protection that goes on top of those, at a very minimum, on top of those passwords. So those are the sort of things that I'd be looking for, that's above and beyond just identifying a vulnerability of a man in the middle.
Great, Michael. Thank you for that. Another question we have is, and I'm going to kind of read this a little bit, so hopefully you'll pick out the key items. Are there any tools to perform man-in-the-middle attacks against social apps such as Viber, Tango, Hangout, etc., without configuration on mobile devices, without reconfiguring default gateway, it looks like? Um, Hopefully that's enough information, Michael. Can you provide some commentary on that?
So basically, sounds like the person's asking if there are any sort of tools to perform man in the middle without having to do any sort of configuration on the mobile device. I think that's correct. You can do that, yes. It's a little bit more of an advanced setup. I have done that a little bit. It involves setting up more of a rogue base station or something like that, where you're not configuring that mobile device specifically to go to any sort of middle. It'd be more like I believe the term is a transparent proxy, so that application doesn't even know that there's anything going between it and its final destination. So I would encourage you to look at maybe researching transparent proxying, and maybe some of the arrow dump, arrow crack type information for a little bit more on that. I think that may be the route that you would want to take. And then websites or other resources to get a deeper technical understanding. I would honestly recommend starting out with some of the links and some of the articles on the OWASP website, and from there, the Kali Linux distribution actually has a very good discussion forum that may also have some technical information that I think you're looking for.
Great, Michael. We really are getting close to the end of the hour. I think that I am going to ask one more question here. And that question is, and it's a nice kind of lead in, I think, to the next session in January, but do I have to have access to source code to pen test a mobile app?
That's a good question. No. The answer is you do not have to have access to the source code. There are a lot of different ways to analyze a third-party app. There's some open source disassembler products. In fact, some of those are included within, most of the ones that I might recommend are included on the Santoku Linux distribution. In fact, I believe in part 3 of our webinar series, I believe be covering a lot of that information on some of those tools that are out there and how to use those. So I would highly encourage you to tune back in to that series. I believe, Sam, you said that was in early January. Highly encourage you to go to that.
That's great, Michael, and you're right. It is January. We will be including a link to register for that session in kind of follow-up communications on based on this webinar. Michael, I'm going to close it out unless there's anything else you wanted to say before we ended.
Yeah. Thank you, everyone, for coming out today and attending this webinar, and please stay tuned for part 3. Thanks, everyone.
Yep. Thanks again, everybody, and keep your eyes peeled in your inboxes for more information about that additional session. All right. Thank you. Goodbye.